Okay, this is the final bit of preparation for our boat monitor. So just do some more checks on the case. I 3D printed for it, so at the moment it's looking like that. I need to check that the components I'm planning on putting inside all fit, that I can wire them up. And I'm going to just do a quick test that if I connect up to the power, that the old LTE code from ourLora still sends data through to the ourLora project. After that, I'm going to take it out to my boat, make sure it fits. I'm expecting to be able to put it underneath the solar panel controller in my boat. I also need to get some measurements because I'm going to build through 3D again the bilge water level sensor mounts. So I need to check where those go in the boat. And finally, after that, I just need to go into VScode and make sure all the pieces I need are there. So I'm going to bring over the Python code that I was using in ourLora, and also I'm going to have to change the routing a little bit so the LTE messages, instead of going to ourLora, now goes to OurBoatMonitor. So I'll test that out. Hopefully all that will be successful, and in our next videos I'll do a deeper dive into actually creating sensors and getting the sensor data to the back end. Okay, I think we're close to a usable case here. So this is what the lid looks like with the Lupincorp logo on it that clips into the top of the base there. And there you see everything fitted in. I did a little bit of wiring. This is telling me that I may still make some changes, but you can see now I've got lugs on the case so it can connect up to my boat when I mount it. To see the aerial here, you see the battery here. I actually moved it out even closer to the wall, but it's in nice and firmly. I may still put some double-sided tape underneath it just to hold it once I do it for real. You see here on the actual Pycom board, if I take the actual Pycom unit out and unscrew these. So on the bottom here I mounted a connector, so it's a right angle connector, and this allows me to get the IoT pins available, and that's going to be used for measuring water, bilge water depth. So I'm going to have some switches for doing that. It's also going to measure the battery voltage of the battery coming in. Other thing to show here, I just started to mount this. I don't think I'm going to put these connectors in this way, but you see I want to be able to plug in this power board. I think what I'll do is I'll have wires coming out of here and have it actually plug in at this end, and maybe move this connector around to here because I've got a lot more space down here. But what we can see here, bring the multimeter over. And turn on the power on there. And let's just check the power I'm getting from. So it's 16 volts coming in. Then if we check the voltage coming out, just a little bit over 5 volts, and I can adjust it with that rheostat. And I can actually change the voltage, so something more like a boathouse battery, so again 12 volts, and hopefully we'll still see 5 volts coming out, which looks good. So I think the power supply is going to work well there. The other thing I've got on here is this little housing for the humidity and temperature sensors, and I made this cap that will go over the top, so they'll seal it up like this. Holes in the bottom of the cap to allow access to the electronics of the you can see here the humidity sensor, so it gets mounted there on some pins, and then this whole thing can be sealed up here with a little bit of silicone around the edge, so there's still holes with access to the outside humidity and temperature, so it can measure the outside without the outside getting into the case. So I think that's looking pretty close to ready for use. Like I said, I'll probably move some of these things around a little bit, be working through how these connectors work, but I think this should do the job. One last bench check, just to check the wiring inside the device. So I put 12 volts into it, and we should start see it blink as it runs the old ourLora LTE code. And we see in Hologram that the data's been sent over LTE, being received, and then if I go to ourLora and I have a look at one view I set up to see the data coming in, and I see that data being received in ourLora. So we should be good to go. Just need to do one final check that the case fits okay in the boat, and then I'll start on the sensors. The boat's covered up for the winter, but I'm going to go in and see how my boat monitor box and fits. I think I'll just go under the solar controller, but we'll find out how good a fit it is, whether I need to make adjustments to where things go. I'm also going to put some bilge sensors in. I think I'll put it on the front wall, but I need to see whether that's really going to work out, get some measurements for how I need to build it. I think I'm going to have to 3D print something to hold the actual sensor switches in there and still have some adjustments so I can move them around a bit. Bit darker in here, so we'll open up the door, hopefully there's no rats, and go try fitting the case, see what it looks like. We're in the boat, so this is the way I'm thinking of mounting the boat monitor, so something like this underneath the solar controller. This is the solar cell connector. I probably just need to move that out of the way somehow, so either through here, have it connect some other way so it's out of the way. The power for the boat monitor comes in here like I showed earlier. I'll probably move the sensors down here or onto this side. Maybe on this side would be better, because those sensors will go off to a bilge measurement sensor down there in the bilge. Okay, the bilge monitor is going to go behind this piece of fiberglass wall here. Give me an idea of how far down it has to go. Height there. And so I think my boat monitor location should be good. I've got the lugs, I can screw it down fairly easily, and should be able to reach both the power and the bilge monitor from this location fine. So a bit of rearrangement of the wires above and we should be good. Okay, I'm now ready to add some sensor hardware and also do the Python programming to get that sensor data sent through LTE back to my OurBoatMonitor application. So this shows the Pycom's PyTrack board. So this is the one I'm using to get the GPS. So the bit I'm interested in at the moment is this little sensor header here, and showed on the previous video where I've got a right angle connector to that. So I'm really just picking up the information on these first pins here, 1, 3, 5, 7, 9. That's all I need. So I just need to pull off one row of pins at the moment, and that's going to be the ground, the 3.3 volts, IO0, IO2, and IO4. And if we have a zoom in on that to see what I'm doing, so ground, so I'm going to have two sensors to just check whether bilge switches are open or closed. So if they're closed, it means the water's level reached that level. So just a simple switch on off type switch I'm going to have on these connectors here. And basically I'm using a pull-up resistor of 10k up to the 3.3 volt voltage high to keep these high. Unless the switch is closed, it'll be closed to bring it down to ground, in which case it'll go from basically high voltage to zero voltage, and that's what IoT 0 and IoT 2 will be looking for, is whether the first water level was reached or whether the second water level was reached. The other sensor I'm going to have is on the voltage of the house battery or the boat battery. So again, I'm going to use the ground line, and going to have a simple voltage divider on that, so going to have a 100k resistor coming in from the boat battery over a 10k resistor pulling it down to ground level. And this is the calculation over here showing what happens. So basically the calculation for a voltage divider is R2 over R1 plus R2. So in my case, R2 is the 10k, so 10k over 100k plus 10k will divide it at a ratio of 0.0909. And the result of that is, because the high voltage that the ADCs on the ESP32 can reach is 3.3 volts. This will result in it being able to read a maximum boat battery value of 36 volts, which is way more than I need. I thought I'd need to cover at least, say, 15 volts just in case it's being pulled high by some sort of recharger, but don't think it'll ever get to 36 volts, but that's okay. So it should reach maximum voltage it can read of 36 volts, and it'll read it with a resolution with the ESP32 that has a, I think, 4096 step resolution on the ADCs. So that'll result in a resolution of about 0.01 volts, which is a lot more than I need. I really just need to at the most measure within 0.1 volts resolution, so should have a lot more resolution than I need out of this, even with having it being able to support 36 volts. So that's the plan. Let's have a look at what the hardware looks like at the moment. This shows how I'm wiring things up. So I have the right angle connector from the I/O header on the PyTrack board. Connects up to my resistors, my pull-up resistors on this little component board, which is really ugly at the moment. I'm going to redo that. And then that all connects into the case like so. So again, I'll probably move the resistor board onto the side and make it a lot nicer and not use hot glue. Okay, some more clean up to the OurBoatMonitor code. So in the MicroPython folder I've got here to hold the MicroPython code, I actually brought over the code that I had in the NB-IoT project for under ourLora. So you can go over and look in the ourLora stuff to see what was happening here. But basically this is the code that picked up GPS data off the Pi tracker board and sent it through LTE up to Hologram. So I basically brought all that code in. One thing I did do is a change in main just while I'm debugging this thing. So I won't be doing GPS while I'm testing things out. So I'm just doing one iteration of that so it doesn't hold things up. Because I know doing this inside, away from the window, I probably won't get GPS, or it'll take forever to get GPS settings, so I won't worry about that. And then there's a little bit of code I just put in here while I'm messing around, so even if I don't get any GPS data, it'll go and set the GPS longitude and latitude, and then just go through as I was sending that through LTE. So using LTE helper. Again, more on all this stuff is back in the ourLora video blogs, and then send it away. So that should be ready to go. The one other change I made here in the project while I was getting this ready is down in triggers I had to set up the environmental variables for all the passwords and user codes that are used to talk to external services from the Firebase functions. I had them in ourLora, so I basically repeated it here. Then the last thing I'm doing is in Hologram, where I had the LTE data going to ourLora, I'm now going to have it going to OurBoatMonitor. So let me just update that route. And the only other thing I need to do is have it go to ourBoatMonitor.com, the iotBroker. So this should send any data received by Hologram off to OurBoatMonitor iotBroker now. And then again, up in the back end functions, it should receive that and sent it on, in this case, to the OurBoatMonitor application instead of doing it to ourLora. So I should be able to start seeing the results in OurBoatMonitor. So if all that works, and I'll just do a test from my my Pycom board that everything goes through, then we should be in a good state to start testing, adding sensors to the board. I've got the basic hardware, and I've got the basic flow of data going through LTE to OurBoatMonitor. Okay, to test this out, I updated the Python code with this code I've got here now, and I plugged my board in, and you see it went through here, just did one GPS receipt, and then send this data through LTE. If I go to Hologram now, so there's my new routing to OurBoatMonitor. If I look at activity, I can see it actually sent and received it in Hologram, the LTE data from OurBoatMonitor, and sent it on to OurBoatMonitor. So now if I look in my functions here and look at the logs, so I can see here, working up from the bottom up to the top, received the data, iotBroker processed it, saved it to the event log, and finally if I look in the Cloud Firestore, if I look in events, this is the first event that I probably created. So under events, I just see one document, and it's a record of the humidity information coming in from the board. So it looks like that's all set up. So I'll cut off the video here, but I think we've got the board transmitting. Now next video I can just dive into sort of the hardware and sensor data side of things. So looking to get the bilge water level sensors working, the battery level sensor working, and probably the following video I'll then look at the I2C sensor for humidity and temperature in the boat.